Okay, so we're gonna start a new section. So you watched the asynchronous video about vectors in 2 dimensions. Now we're gonna talk about vectors in 3 dimensions. Woo woo! Woo! Okay, something's not working. It's not switching. No! What happened? Why are you broken? Switch. Ah, there we go. Nice. Okay, cool. Okay, so we're going to talk about vectors in R3. In other words, vectors in 3 dimensions. Okay, so first of all, how are we going to draw this? We only have a piece of paper, but we want to draw 3 dimensions. So we need to talk about how we're going to set up our axes. So, let me put my little writing thing here. There we go. So when we're talking about R2 or the coordinate plane, there are 2 ways you could set up the dimensions or the axes, because you have 2 different axes. Actually, there's a variety of ways you can do this. So let's talk about this. So this normally is my x-axis and this normally is my y-axis. Does it make sense that I could switch them? Right, you could make the horizontal one your y-axis and you could make the vertical one your x-axis. That's one choice you can make. There's also another choice you can make, which is completely arbitrary, but like we follow it. So if you go to the right of the origin, usually these are positive numbers, and if you go to the left of the origin, usually those are negative numbers. So this part over here, we could call it the positive x-axis. And this part over here, we could call it the negative x-axis. You could switch that if you wanted to. Like, there's no reason why the negative numbers have to be on the right and the positive number. There's no reason why the positives have to be on the right and the negatives on the left. If you wanted to, you could switch them. Maybe you've never thought about doing this before, but you could. So we're going to have similar sort of decision to make when we're dealing with R3. Because we have axes. We have one axis. We have another axis. And these are at a right angle to each other. And then now you have this extra axis that's coming out from them. That 3rd dimension. Okay, so right here, that point, that's the origin. Now, the origin in 3 dimensions is 0, 0, 0. As opposed to the origin in 2 dimensions, which is just 0, 0, right? You went from 2 dimensions to 3 dimensions. So now we have to decide which axis is what and where are the positive numbers. Okay, so the red one is going to be my z-axis. Which we can think of as height. Goes like that. And now the other 2, you could choose which one will be x and which one will be y. And we have a particular way of doing this. This one will be x. This one will be y. And now you have to decide where the positive numbers are going to be. So this stuff right here, this is your positive x-axis. And if you go like into the screen, that would be the negative x-axis. Now you have to make the same decision for the y-axis. Going this way will be the positive y-axis. Going this way will be the negative y-axis. You could set it up other ways, but this is how we do it. And there's actually a way to figure this out so that you don't have to memorize all of this. So there's something called the right-hand rule. Oh, actually, wait. Let me back up a little. I didn't tell you on the z-axis which part was positive and which part was negative. So for the z-axis, going up will be positive. And going down will be negative. Does it make sense, those little tick marks? Like those are the tick marks for the axis, the little things that I'm putting. Okay, so there's a rule to figure all this out, and it's called the right-hand rule. So use the right-hand rule to recreate the axes in the correct fashion. Okay, so the right-hand rule works like this. You have your right hand. And interesting thing about your hands is that they are mirror images of each other. If you do something with your right hand, it will do, in some sense, it will be opposite to whatever you do with your left hand. So the way it works to use the right-hand rule is that your thumb always corresponds to the positive z-axis. So I'm going to like draw this. I'm going to like draw a really horrible looking hand. There's a hand. So your thumb is the positive z-axis. So, okay, cool. And your hand starts at the positive x-axis. Or your fingers, let's say your fingers. So you line up your fingers with the positive x-axis. Line up fingers with positive x-axis. Okay, so you have your hand like this. You're like, okay, I put my finger, this finger, on the positive x-axis. And then what you do is you rotate your hand towards your palm. It should be able to rotate to the positive y-axis. Your palm should... So you rotate in the direction of your palm and you should get to the positive y-axis. Let's write that down. So rotate in the direction of your palm, and you should rotate to the positive y-axis. So what happens is, if this is my x-axis right here, and I can rotate to the y-axis, the z-axis is up. If you try to do that with your left hand, you would see that this doesn't work. Because if you have your... So, let me like sort of draw the picture. Your hand is right here. And your palm is this way. So you would rotate like this. If you were to do this with your left hand, your palm would force you to rotate that way, and you would rotate to the negative y-axis. Hopefully that makes sense. I'm gonna pause for a second. Was that like super confusing, or are we like on board with this idea? Because like think about it, if you take your two hands and you rotate towards your palm, they rotate in opposite directions. So you always rotate like how your right hand would rotate. You rotate in the direction of your palm, not the back of your hand. So that orients you, it's called. Okay, cool. It's actually a really good picture in the book that shows it too. So if that's not making sense, I highly recommend you look at it. Okay, so let's look at how this works. So let's plot the point 1, -2, 3. Okay, so surprise, surprise, it always goes x, y, z. So doing this by hand is interesting. So you set this up, you're like, yay, here's my x-axis. Yay, here's my y-axis. Okay, now you have to remember that this part's your positive x, this part's your positive y, this would be negative x, this would be negative y, and then you've got your z, oops, okay, that was really ugly looking. Okay, then you've got your z going like this. Positive z, negative z. Okay, so this works basically just like how you would sort of expect. Right here you have 0, 0. So you first follow in the x direction. So I want to go positive 1 in the x direction. So I put a little tick mark. And I'm like, okay, 1, 2, 3. So you walk out to 1 on the x-axis right there. You move 2 in the direction of negative y. So 1, 2, 3. So you end up having to walk in this direction to right here. So that point right there, that is 1, -2, comma what? That little green point right there, which is on the xy plane. What's its z value? 0, yeah, because we haven't gone up or down yet, right? Do you see how we moved 1 in the x direction, and then now we moved -2 in the y direction. Okay, so you've got that little point right there. Now, the 3 tells me I need to now shoot upwards 3 through the z-axis. So now I'll put these little dots like showing, oh, I'm going up. And this is our final point. 1, -2, 3. So you sort of have to like, if you're drawing this, you sort of need to show 2 points. This green point on the xy plane, and then the actual point you want, which is in space. Imagine you had like a flashlight. Okay, that looks like a can, but whatever. And like the xy plane was the ground. Does it make sense that this would be the shadow from the point as the light goes down? Right, so you want to see where, so like if you have your point in space, you want to imagine that there's a light shining down. You want to have the point that's directly underneath it on the xy plane, so you can like see how high it's gone up for perspective. How I got 0 to be my z if I did not move 1 down. What does that mean? Oh, so, okay, you're talking about this blue dot right here? Okay, so that blue dot right there has moved 1 in the x direction, 0 in the y, and 0 in the z. So I started off here at the origin, 0, 0, 0, and I moved 1 in the x direction. So I went from here to here. Okay, and then going from here to here, I moved -2 in the y direction. And then from that one to that one, I then popped up in 3 in the z direction. I probably should have put that 1, 0, 0 for the first point. Yeah, where it was. Yeah, it's on the XY axis. Oh, sorry, the XY plane. Okay, so we need some names for these different things because I keep on talking about the different planes. So this will be X, Y. Okay, that was ugly. What the hell did I just do? There we go. Sorry. Z. Normally you put the X, the Y, and the Z in the positive direction. Okay, so I'm going to draw some lines which are parallel to the y-axis. Does everyone see my lines parallel to the y-axis? And now I'm going to draw some lines parallel to the x-axis. Those lines taken together, which plane are they? It's like flat. Oh yeah, I can quickly go back there. Yeah, that's the XY plane. So what I have drawn there is the XY plane. It is flat. Okay, now there's several planes that you can make. So we're gonna draw them. So that one's the XY plane. Let me move this thing. Good. Let's do that. Okay, I didn't select everything that I wanted. Okay, so that's the XY plane. Okay, let's draw another one. So I've got my y-axis. Got my x-axis. I've got my z-axis. Okay, so I'm going to draw some lines parallel to the y-axis. And I'm going to draw some lines parallel to the z-axis. It's sort of a little hard. Actually, what I should do is then redraw this. Okay, do you notice how the white line is on top of those lines? But the white line in the negative x-axis is behind the white lines? That is the that is the zy plane, or yz plane. It's like a vertical sheet of paper going like this. The xy plane was like this. The yz plane is like this. Okay, and we're going to talk about how you mathematically describe these. And there's one more we'll talk about, but let's go back to the xy plane. So if you look at the xy plane, if you choose any point on this plane, what do the z values of those points have to be? So I have these like red dots, they're all on the plane. So what do we know about the z value? Yeah, there's 0. So the way you describe the xy plane is you say, well, the xy plane is a bunch of points. It is some x, y, and z points. Okay? And those points are the points such that z equals 0. Okay, so the xy plane is just all the points in R3 where the z value is 0. That's how you get that flat surface. Okay, what about the YZ plane? If you choose some points on the YZ plane, we'll do them in blue now. What do you know about the X value? Because they rose up out of the Y-axis, right? I drew lines which are parallel to the Y-axis. What do you know about the X value of these points? Yeah, so what do we know? Yeah, they're also 0. So the YZ plane is comprised of x, y, z, points which have x, y, and z values, and we know that the x value is 0. So notice the name sort of makes sense. The y's and the z's, they're the ones that could be something other than 0. Same thing over here. X and y are the things that could be non-zero. Right? Because z is 0, x is 0. So the stuff that's 0 that's not in the name. Okay, we've got one more plane to talk about. We'll start off by drawing our z-axis, our y-axis, and our x-axis. Okay, so we've done xy, we've done yz, so that leaves us with, we need to do the xz plane. So I'm going to start by drawing lines which are parallel to the x-axis. These are coming, like you're taking copies of the x-axis and you're going up and you're going down. And then I also want lines which are parallel to the z-axis. So if you start looking at points on here, what do you know about the y value? They are equal to 0. So the xz plane is just a bunch of points with x, y, and z values such that the y equals 0. That's what that means. Okay, so these are the 3 named planes that you need to know about. Okay. Questions so far? Cool. Okay, I'm gonna scroll down a little. So let's say that you have 2 points in 3-dimensional space. So let's say one of your points is called x1, y1, z1. And your other point is called x2, y2, z2. And you're wondering, like, well, how far away are they from each other? So let's call this one point A. Let's call this one point B. So you're wondering, hey, what's the distance between point A and point B? We have a formula for R2. There's also a formula for R3. And thankfully, it is super similar to the one from R2. So the distance formula has a square root. Now, normally, what would you do with the x values? Like, what would you do with the values if you were in R2? Like, how would you get the distance between one point and the other point? How would you describe that in words? Honest question. Well, what do you mean by x squared plus y squared? So should I just put like x1 squared plus y1 squared? Cool. There we go. You take the difference of the values and then you square them. So you take the difference of the x's and you square them. You take the difference of the y's and you square them. And that's from the Pythagorean theorem. And then basically you do the same thing, but you keep going with the z values. Boom. It's actually not too hard to show that this actually works. It's pretty cool. I recommend you go through and actually see, like, draw it. It's an interesting experience to calculate this formula. What I'll point out is that, let's just say that this is like the y-axis and this is the x-axis. So what you would do is you would move out x1 in the x direction. You would move out y1 in the y direction. So you get this point right here. x1, y1, comma 0. Does everyone get that this is a point on the xy plane? Because I have x1, y1, comma 0. And then how much would you go up from that point by? So like I have that, it's like a little rectangle on the xy plane. Now how much would I go up by? So I have to like go up. How much would I go up by from there? Let's just say z1. I'm not sure. Maybe people are thinking. So you would go up. And then you'd have the point x1, y1, z1. And if you think about if you want to calculate the distance that this is from the origin, what you're doing is calculating from the origin all the way up to here. And what you could do is you could first calculate the distance from the origin to this point. And then you could calculate this point. And you could use, let's call this distance A, and let's call this distance B. The distance C that you want would be the square root of A squared plus B squared. And you could see that you end up getting something super similar to this formula. Okay. I won't bore you with doing an example of that. It's just plugging in numbers. Alright. Let's talk about equations in space. it's not letting me. It's not letting me write. Oh, look. Oh, it moved this way. No wonder that's what happened. Okay, so let's talk about equations in space. Equations in R3. Okay, so let's talk about the xy plane. What did we know about points in the xy plane? Like, what did we learn about them? So if you were to talk about points in the xy plane, what could you say about them? Okay, I'm gonna help you out. I'm gonna scroll up a little. There's your xy plane. What do you know about all of the points on the xy plane? Z is 0. Thank you. Okay. So this actually helps you figure out how to write the equation for the xy plane. The equation for the xy plane is you just say z is 0. Because that is for the xy plane, that's always the case. The z value is 0. Okay. So if you ever run into an equation like z equals 5, that's a plane which is parallel to the xy plane, but it's been floated up by 5 degrees. So let me draw a picture. If this little sheet right here is your xy plane that has an equation z equals 0, the equation z equals 5 is parallel to that, but it's been moved up by a distance of 5. So I'm gonna draw some little lines so you can imagine this is a floating sheet of paper, and then here's your floating sheet of paper, which is the xy plane. Z equals 0 is the xy plane. Z equals 5. So you start off like this. Here's your z equals 0. Z equals 5 is the same thing moved up by 5. Yeah. So what you've been dealing with is you've always there's always been more, but you've just constrained yourself to thinking about z equals 0. Thinking about it here, yes. That's a good way to put it, yes. Okay, so if you ever have an equation z equals some letter A, that's just some plane which is parallel to the xy axis moved up or down by that amount. Okay, so there's some other planes we need to talk about. Let's talk about the YZ plane. Okay, for the YZ plane, which variable is 0? What's the equation for the YZ plane? Yeah, x is 0. Cool. So you know that the yz plane is simply the equation x equals 0. So let's draw the yz plane. The yz plane looks something like this. You've got your sheet of paper, and it's like standing up on its side, right? Because your y-axis is the z-axis, and this is the equation. That plane is satisfies the equation x equals 0. Now, if you wanted to talk about x equals 5, it's parallel to the yz plane, but it's been shifted over by 5. So we've moved it over by 5. So do you see how they're like two sheets of paper standing up like this? This is like x equals 0, and then you would move over by 5, and you would get x equals 5. They don't touch. You took one, you moved it over. Where would x equals negative 5 be? Yeah, behind. Yeah, exactly. You would move 5 behind. Because remember, this is positive x and this is negative x. That's why we know that's on that side. So you would draw it like this. So hopefully that's sort of making sense. You see how I drew it so that you can like see which one's in front? It's like sort of shade this so you can see that. It's more like that. Right? So what's the equation for the xz plane going to be? Y equals 0, thank you. Boom. And the xz plane looks something like this. Right, because you have the x-axis, you have the z-axis. This is y equals 0. And then if you wanted to graph something like y equals 5, you would get this other sheet of paper which is parallel to it but moved over by 5 in the positive direction. If you wanted y equals negative 5, you move in the other direction. Does everyone see that there's sheets of paper like this now? You like move them over. Okay. We're just gonna end early today. This is a lot. We'll return to this. So say I was here. I'm really hungry. I want to go eat some breakfast. I didn't wake up early enough. So we're gonna stop.